Hi guys, welcome to Exponential Transformation. So what we're going to do is we are going to see how these functions are moved up and down and left and right and flipped over and stretched. So remember our little transformations cheat sheet that we've used in every one of our lessons. You can look and see that if your function, and our function is the exponential. Now, I'm going to remind you that the exponential parent function can have any base. It could be a base of 2 to the x. It could be a base of 5 to the x. It could be a base of 10 to the x. It could even be a base of e to the x. Remember, that was that Euler number that we briefly talked about the other day. So remember that the base is just the number with an x exponent. That's the parent function. Now, what are we going to talk about with that? Well, anytime we have a plus at the end or a minus at the end after our function, after our exponential, plus means up, minus means down. Now, if your plus and your minus are with the x, that means they're up in the exponent. Plus means left. Minus means right. And then, if your minus is in front of the exponents, like negative 2 to the x or negative 5 to the x, that's going to be a reflect over the x-axis. Means it makes it go upside down. And if there is a minus inside the exponent with the x, so up there with the x in the exponent, that's a reflect over the y-axis. That means it turns it backwards. If there's a number in front or times the exponential, so like 3 times 2 to the x, that's going to be a vertical stretch. And if there's a number inside the exponent times the x, then that one's going to be a horizontal stretch. That's the one we rarely see. So just reminding you of these. Now let's go take a look at our exponential functions, no matter what the base is. Let's take those parent functions and transform them. So remember, this is what the exponential parent function looks like. He's J-shaped. Remember that. And down here on the x-axis at y equals 0 is a horizontal asymptote. So he never goes below the x-axis in the parent function. Now, I did 2 to the x for the base is 2, but you could have any of these be any base. It could be 10 to the x, e to the x, 3 to the x, any number you want for the base, and it's still going to be J-shaped kind of parent function. Now, what we're going to do is we're going to move this parent function around. So what transformations occurred in f of x is 2 to the x plus 2. Well, now we're going to go over here and we're going to look at it. 2 to the x, that's the parent function, base is 2. What happened to it? Well, over here at the end, we have a plus 2. After that, not in the exponent, but big plus 2 means up 2. That's the transformation. And if you look from your red function here to your blue one, it did go up 2 spaces. You can confirm these in Desmos. All right, let's look at this one. So we'll go back and look at the parent function. What transformations occurred in f of x is 10 to the x minus 3 plus 2. So 10 to the x is the parent. The base is 10, x is the part of the parent function. So one of the things I noticed is the plus 2. We know that's at the end, so that's up 2. But the other thing I noticed is this minus 3. Minus 3 means it went to the right 3. And that minus 3 is in the exponent with the x. That's how I know he's left and right. So I'm going to look at this. Does it look like from my red one, we went up 2 and right 3? Yeah, it does look like it did. And it doesn't matter what the base is. Remember, the base just makes it a steeper j or a less steep j. All right, let's see what happened in this one. So the parent function, let's see if we can figure out what he is and then what transformations happen. F of x equals negative e to the x minus 3 plus 2. So the base is e, so e to the x is the parent. So we're going to dissect what happened. At the very end, there's a plus 2. We know that's up 2. There's a minus 3 in the exponent with the x, so that means it went right 3. And then right here in front, there's a minus sign. A minus in front means it reflects or goes upside down, reflects over the x-axis. So let's see if he did that. From the red one, he would have had to gone up 2, right 3, and then flipped upside down. It's hard to see it, but that is exactly what he did. He went up 2, right 3, and flipped upside down. All right, let's see if we can figure out these ones. So negative 4 times 2 to the x minus 3 plus 2. So I got to find the parent function. 2 to the x is the parent function. So the base is 2, x is the exponent. Now let's start tearing it apart. At the end is an up 2 in the exponent, right 3. In front, there's a negative, so that's the reflect over the x-axis. And then right here, this 4, that's times the 2 to the x, so that's a vertical stretch by 4. So our function has flipped over. I can definitely tell he's flipped over. He's supposed to be taller. It's going to be hard to see that he's actually stretched, but he has been stretched. And he should have moved to the right 3 and up 2. And he has. It's hard to tell it with him upside down, but he has done all those things. So now what you're going to do is you are going to find, no matter what the base of the parent function is, what transformations are occurring